from the beginning, both the black and the white. All it was there was a change in the proportion of the black and the white peppered moths. And she steps back, looks at me, and goes, well, then what was the point?
That's a good
And I'm like, yeah, exactly.
Just like Lucy.
And they want to claim that's such a wonderful example of evolution, but it didn't accomplish anything because they were all there already to begin with. And then with Lucy, as I was telling Russ, right? Yeah, you're Russ. Yeah, Bill Russ. Okay. You can see this on YouTube because so much is on YouTube now, but in 1996, I think it was, PBS produced a 3-part series on the origin of mankind, and Donald Johanson was the narrator. Now, Donald Johanson was the team leader of the archaeologist, geologist, paleontologist that discovered the Lucy fossils. All right, so he was the narrator, so it wasn't like this was done without him being heavily involved in production. They interviewed Owen Lovejoy, who was the primary anatomist that worked at reconstructing Lucy. And in this interview, he admitted Lucy's hip bone didn't work right. She was too hunched over, so we cut it and straightened her up. They admit that. Now, you see, you have to understand, to them, that's not dishonest because we know she walked upright. Therefore, there was just some damage to the hip bone we had to rebuild. That's the way they look at it. Okay, so that's being passed as science because what's the overriding paradigm? Evolution is true. Therefore, everything has to be focused through that truth of evolution. Okay. I want to focus a little bit on dinosaurs. Because you got as part of the tour, you got to see some dinosaurs, obviously, and I was told to talk about some of the research that I'm doing right now, which involves dinosaurs. I am not a paleontologist, even though I have been referred to in the media as a vocational paleontologist, which is a little amusing to me because I never even was with 2 miles of a paleontology class. I am a molecular biologist, but I have a very heavy biochemistry background. And suddenly biochemistry is becoming very important in the study of dinosaurs, as we'll get into as we go into this. And I work for the Creation Research Society, not to be confused with the Denver Society for Creation. Okay? It's like, you know, First Lutheran, Second Lutheran, not the same organization. Maybe they talk to each other, maybe they don't, you know. So anyway, okay, so the Creation Research Society was founded in 1963. We're actually the oldest of all the major creation ministries. We're one of the least well known because our focus is on the science. And that's obviously not something that catches people's attention all the time. So as part of working for the Creation Research Society, I am continuing my science career and continue to do research. Okay. Here we go. Radiometric dating methods prove rocks and fossils are millions of years old. Therefore, the debate is over. And that's really what the world would want you to accept right now. The debate's over. Shut up, sit down, behave. Don't talk about it. Don't challenge, don't question. So this is where we are as far as the world's concerned. But obviously, as you saw in the tour, and as I'm going to explain to you, the debate's far from over. They're just trying to shut down the debate because what happens when you're losing the debate? You want to shut it down. You don't want to admit you've lost the debate. So it's like, okay, well, we know better, therefore you just be quiet. And that's what's happening. All right. Radiometric methods, though, see, were actually not developed until the early 20th century. And that's important to keep in mind. They were not developed until the early 20th century. Relative dates, relative geological dates, were assigned decades before any radioactive dates were ever worked on. In fact, Charles Lyell in the 1830s published a 3-volume set of books called Principles of Geology. Now this becomes very important because Darwin took these books with him on his Beagle trip around the world where he began to first formulate some of his ideas that later appeared in Origin of Species and then later on Descent of Man. And he read these, by his own admission, read these over and over. And in fact, he even attributes, he says, I can't express strong enough that half of my ideas came out of Lyell's mind, out of his brain. So these were highly influential to Darwin. But the irony is that, let's see what the irony is that Lyell, even by the admission of evolutionists today, Lyell did a lot of sophistry, a lot of wordplay, a lot of loose with the facts, but didn't really do a lot of science. In fact, anyone know what Charles Lyell's actual professional training was? He was a lawyer. That ought right there tell you. He was a lawyer, which meant he was skilled at the argument. Right. But he didn't have training as a geologist. Yet he is writing all of this. And we have a letter that he wrote after publishing this book where he expressed that my purpose of writing this was to rid the science, as in the science of geology, of Moses. In other words, I want to get Genesis out of any discussion of geology. So the way he chose to do it was to begin to say, see, this stuff is so old that obviously doesn't fit with the biblical text, and therefore you throw the biblical text out. That was his whole purpose. All right, so what we see is, using radioactive dating, scientists have determined the Earth is about 4.5 billion years old, ancient enough for all species to have been formed through evolution. So they fall back on radiometric dating as their evidence, even though, as their evidence of the Earth being old enough, but the primary purpose is the second part. In other words, we've got to have an old enough for evolution to be able to occur. That's what they're really seeking after. But remember, radiometric clocks were not proposed until 1907, and adequate equipment didn't even exist until the 1950s. So how is it radiometric dating was such an important key in determining the age of the Earth at that time of Lyell and of Darwin and of Huxley and even into the early 19th century? Because you really couldn't do it. They fall back on it now, but that's not what was used to actually establish the relative ages of these geologic formations. In fact, I would challenge, if when they finally did begin to apply radiometric dating in the middle part of the 20th century, and it did not give the already assumed old ages, would have been accepted. See, the paradigm of old ages, the paradigm that this is 2, 3 million, 5 million, 10 million years old, was already there. If the radiometric date gives them a 20 million year old age, oh, okay, well, that's fine. But if the radiometric date gave them a 20,000 year age, what would they have done with it? Yeah, oh, that obviously there's an error in the method. Yeah. See, so radiometric dating is not a external verification of the assigned dates. It's a product of those assigned dates. So it's circular. Circular. All right. Why are dinosaurs such a favorite of evolution? And I think this museum, regrettably, is a classic example of that. It's a favorite of evolution. Why is that?
You're entertaining.
Yeah, very entertaining, that's true. That's true.
They're big, they're impressive, and people can't disprove.
And they have this high fascination for who? Kids, yeah. Almost all kids go through a phase where they're very attracted to, just taken by dinosaurs. And even after you outgrow that, you really don't totally lose that. And what you learned by going through museums like this about dinosaurs still stays with you even after you maybe you can't remember all the names of the dinosaurs anymore like you could when you were 7. Okay? But that thing there, 60 million, 100 million, evolution, that still stays with you. So they're great indoctrination tools. All right, so what do you think of when you hear the word Jurassic? Yeah, you think of the movie? Yeah, what is it besides the and even in the movie, in thinking of the movie, what's the movie about? Yeah, it's about dinosaurs. So when you hear the word Jurassic, you think of dinosaurs. You think of the age of dinosaurs, the time of dinosaurs. The idea is to set up in your mind that there was this period in sometime in Earth history past where we weren't here. Cows weren't here. Dogs weren't here. Dinosaurs were here. And if you begin to accept that scenario, that historical reconstruction, then it's very easy to see, well, evolution would seem to fit that, because obviously if we and dogs and cows didn't live at the time of Jurassic, then we came in later, so we must come in by evolution. And so they can use that simple historical reconstruction to make you amenable to further arguments of evolution. What I want to work today is to show you that Jurassic is nothing like that. That's total fictitious. All right, so the popular view is, of course, that we have the geologic column of all the various rock layers and the types of fossils found in those rock layers, and that there came about 250 million years ago a period called the Jurassic, where dinosaurs first began to appear, first began to quote evolve, and then you have the Jurassic, which of course is the popular version of the popular word, and then you have the Cretaceous, even though most of the dinosaurs that we know of actually lived in the Cretaceous. And the Michael Crichton, who wrote Jurassic Park, didn't realize that. He thought, oh, I just thought Jurassic sounded cool. But anyway, Cretaceous part doesn't sound but most of the dinosaurs we know of actually lived in the Cretaceous, not the Jurassic. And so that's the popular view. So dinosaurs occupied the Earth sometime 250 million years ago to about 65 million years ago over these three geologic eras. And clearly also then, the way that the geologic column is interpreted is these are periods in the past that occurred sequentially after each other over the course of billions and billions of years. Now, biblical creationists would say, no, this was laid down by the flood and is a single snapshot of Earth history, not a progressive millions and millions and millions of years of recorded history. And as a single snapshot, then that means that these animals and these animals and these animals were actually all contemporary of each other, not evolving into each other. All right, so for a lot of people, because their understanding of dinosaurs, because of the indoctrination we've received about dinosaurs, they view dinosaurs as it allows them to hit the delete button on the Bible. Bible, dinosaurs don't match, you know, hit delete, Bible's disproven. And I don't know how many times I hear, well, science has disproven the Bible. Science has disproven the Bible. Well, first off, what is science?
It's supposed to be a systematic study of whatever.
Even more precisely, science is the tool that allows you to do the systematic study. Yeah. Science is a tool that we humans use to try to understand the creation around us. Now, in today, in contemporary terms, you're going to be taught that science is a tool to allow you to understand natural mechanisms of the world around us. See, they got to put that in there because now that automatically excludes any kind of God, any kind of creator. And so, if you go back to the origin of life, it has to be somehow that life made itself, because science would say you can't bring in something outside of the natural. And so by redefinition, they try to claim the territory and therefore win. You know, if you bring in a creator, well, that's not science, because that doesn't fit my definition of science. But I don't care what your definition is, that's not what science is. The early pioneers of science were all creationists, almost to the man and woman. Okay, they were creationists. They clearly weren't going to agree with our contemporary views of science today. They laid down the pathwork. I think they knew what they were talking about. In fact, Isaac Newton is still considered possibly the greatest scientist that ever lived. And 1/3 of his famous treatise is talking about God in the Bible. So he didn't view it as science's only natural explanation. It's a tool we use to understand the world around us. So as a tool, does science say anything? You know, you take your test tube, put some drops of this and drops of that, and hold it up and say, okay. If it says something, that'd be kind of scary. So what it is you actually use science as a tool which you draw interpretations. And yes, there are some people's interpretations that are not consistent with the Bible. Clearly. But that has nothing to do with science in the Bible. That's their interpretation. So next time you hear somebody talk about, well, science says this. No, science doesn't say anything. That's your interpretation of what you think science evidence is showing. That's what it is. And when it's interpretation, then who does interpretation? God? No, the human. Are humans fallible? Big time. All right, so here we have, here's the situation that is so common in the world today. Little Johnny has a dilemma about dinosaurs. All right? And my teacher says dinosaurs lived millions of years. Well, all of a sudden he's got to think, okay, if dinosaurs lived millions of years ago, then what kind of Earth history is that telling me? How am I to understand what was the history of the past? What is the Bible history versus this kind of history? So this creates immediately in little Johnny's mind a dilemma. He doesn't know which way to go. All right, here we go. Dinosaurs became an age of the earth issue simply because, right, 250 million years ago was Jurassic, 150 million years ago was Jurassic, 65 million years ago was Cretaceous. So we're already setting up these ages that we say, long time ago, millions of years this happened. So people would recognize then just by using dinosaurs that clearly there's a long past history that we really don't see recorded in the Bible. So what's that do to the Bible? Does that mean the Bible didn't record it, the Bible didn't record it right? See, and it creates, in a lot of people's understanding, a contention. And unfortunately, that contention often causes them to say, well, the Bible must be wrong. Okay, we have to recognize, though, first, nature does not possess clocks. Okay, you dig up a fossil, it doesn't have a little clock on it ticking away saying, okay, I am 17.3 million years old. And rocks, the same thing. There's no clocks in there. So it all comes back to we have to make estimates of ages based on something that's not a clock. So for example, rates of physical processes are assumed to will serve as a clock. In other words, the rate of radioactive decay, the rate of sedimentation, the rate of something else occurring is considered, then this could serve as a clock. But the problem when you use this is you're going to get all kinds of different ages. So in the world today, if I say I have two physical processes I can use to measure the age of this fossil, one gives me an age of 20 million years, one gives me an age of 20,000 years, which one's going to win out? Right? Because why? The overriding paradigm in interpreting, because remember science is interpretation, the overriding paradigm is evolution. That's how you can reshape Lucy's hip and still feel it's okay, because the overriding paradigm is we know she walked upright because that's what evolution demands. Right? And then three current rate measurements are simply snapshots. If we measure the rate of radioactivity today, if we measure the rate of sedimentation today, if we measure the rate of seafloor buildup, if we measure the rate of erosion today, they're just snapshots. They're not continuous history. So we don't know how long that's been occurring. We don't know if it's been occurring steadily, if it's been faster, if it's been slower, if it's stopped. We simply don't know. We have to make assumptions. The assumptions may be relatively reasonable. They may not be very reasonable. All right, in fact, what most people don't understand is when you look at any kind of process that has the potential of serving as a clock, 90% of them actually give ages far younger than hundreds of millions of years. These aren't considered acceptable, though. Why? Because they don't get the required ages necessary for evolution to occur. Go back to that previous slide. They like radioactive methods that they use because they give the ages we want. Therefore, they trump everything else. Now, is that really valid? No. There's no reason to say that the radiometric, the rubidium, strontium, or potassium argon trump everything else. It is just that it gives us the age that we want, and therefore that becomes the overriding paradigm. Hey, little Johnny, my pastor, says dinosaurs aren't in the Bible, so they must have lived before Bible times. Or maybe didn't even exist at all. Well, let's look at this. Bear in mind, the word dinosaur wasn't even developed until 1841. So if you're talking about sort of the early texts of the Bible, be they in English or other languages, you're not going to be using the word dinosaur because that word didn't even exist. Now, I would accuse modern translators of being chicken. They just simply don't translate the correct words into dinosaur because, oh gosh, think of how that would go over. But the idea that the word dinosaur itself is not in the Bible is meaningless as far as an argument that the Bible knows nothing about dinosaurs. In fact, in the Bible we have descriptions of beasts of the earth, the great beasts, dragons, and well, obviously everybody knows there are woods and these fire-breathing creatures flying around and destroying things, but that's not what it's referring to. It's simply referring to massive type creatures. Okay? Habitation of dragons, den of dragons, dragons of the wilderness. See, all of these phrases can easily be translated dinosaur, and it wouldn't violate the text whatsoever. In fact, it would be very consistent with the text. There is a Hebrew word, henian, which actually means monster, and it appears 14 times in the Old Testament. Now, contemporary translators will translate it as dragon sometimes, but more likely monster, sea monster, serpent. Even now it's being translated as jackal, which, okay, that's, you know, how do you get from dragon to jackal type thing? But we recognize, see, there was a word in the Old Testament that could very easily refer to creatures that we today know as dinosaurs. But because the assumption is that dinosaurs lived long before any of the Bible history, you know, events were occurring, that it couldn't have been a dinosaur, it must have been something else. And of course, I'm sure most of you are familiar with the text in Job. We have chapter 40, Behemoth. If you look at the description, say strength of the loin, powerful belly muscles, tail like a cedar, and of course this would be referring to the cedars of Lebanon. These are huge, tall cedar trees, not little bitty ones like we have in Arizona, you know, these huge, tall cedar trees. Okay, bones of bronze, first among God's works. Now this becomes really important to consider because when God is talking to Job, what is God doing? Job's a complicated book for us to understand if you're not a creationist. If you are a creationist, then it suddenly starts falling into place. Okay, well, what's happened to Job? What's happened?
He's lost everything,
Yeah.
he's been sick,
Yeah.
he's just
Yeah.
had the worst.
Exactly.
The worst.
Yeah, and I'm just always, I'm so thankful, God, that it was him, not me. Okay, anyway, yeah. So Job, of course, as any of us would do, is like, God, what is going on here? I mean, come on, give me a break. What's going on here? What's God's? Does God ever answer Job's question of why?
No.
Oh, and I think that's fascinating. He never answers the question of why because you know God doesn't tell us why. That's not what He wants us to focus on. He wants us to focus on what. I'm gonna do a shameless pitch here for a second. He wants us to focus on what?
Yeah.
The who, not the what or the why. So what does God do with Job?
At that point, he's reminding Job, I'm God, I created all of this. Where were you
Yeah.
when I created this?
So
and this?
God proceeds to give Job a creation lesson. And I guarantee if it's good enough for God, it's good enough for me. He gives Job a creation lesson. He's saying, Job, I made this, and I made this, and I made this. What'd you do? And as part of that, he points to Behemoth and he says, this is first among my works. Now, if you go into your footnotes in whatever translation you may have, it's probably going to say something like Behemoth is elephant, maybe hippopotamus, maybe buffalo, you know, it's gonna make some claim of some contemporary animal today. Well, since we know God created massive creatures, and God's saying this is first among my works, He's not telling Job, this is first among my works, and if you get a shovel and start digging, you'll find their fossils after a while. In fact, He tells Job what? Go down to the Jordan, you can still see them right now waiting in the reeds. This is the largest, greatest, most massive creature I've created, and just the very looking at him tells you my power. Because guess what? You can't trap him, you can't ensnare him, you're not even going to mess with powerful belly, strength in the loins. See, that fits these large, massive species of dinosaurs. It doesn't near as well fit a rhinoceros or a hippopotamus or an elephant. Yes, they're big, but you know, we trapped them so much that we're driving them to extinction. So it doesn't really seem very appropriate to try to fill one of those in. Okay, how could Noah fit the dinosaurs on the ark? And our tour guides touched on this a little bit. Yeah, because of course, and you can go online and find all kinds of silly pictures, you know, that, there's just no room. I mean, you bring this big, massive thing in, and there's no room, and it's all scrunched up and everything like that. And they use this to mock and ridicule not only the Genesis text, but the whole concept of Noah's flood to begin with. All right, so here's one of our problems. When we think of the ark, is this what we think of? The little cartoon characters that we show our children. Because all too often, for many people, this is what you think of, something like this. You don't really understand what the ark is. If you've not gone to Answers in Genesis, they need to pay me, because I'm putting a plug in for them. But then if you've not gone to Answers in Genesis' ark display in Kentucky, you need to go sometime just simply so you can wipe this out of your understanding and see what it most likely really was and how massive it was. Lots and lots of room on the ark. Incredible amount of room on the ark. So it's not like, well, there was hardly room to put anything. And you got to put food for all the animals and water for all the animals and food and water for all the humans, etc., etc. And so, boy, there wouldn't have been room for anything. When you begin to understand how big the ark was, you recognize just how much space there was going to be for everything. Plus, let's talk biology here for a second. You know, the largest dinosaur egg found is only about 12 inches in size. And it's not like, well, we just haven't found the larger ones. This is a physiological limit to about as big as an egg can get. You see, the hatchling inside the egg is breathing air from the outside. See, for mammals, you have the umbilical cord, you're feeding oxygen to the unborn through the mother. Well, with a hatchling and an egg, they're separated from the mother. They got to breathe on their own through the air, the outside, penetrating through the eggshell. If you get an egg much bigger than 12 inches in size, the shell gets so thick you can't hardly get enough air in, and the hatchling would suffocate. So even the most massive of dinosaurs started out this big. I don't think Noah had too much trouble with those. Let's go. I don't think they took up too much room. I don't think they ate very much. And in fact, these would be the ones you'd want on the ark. There'd be no reason to bring one of the big, massive, giant ones on, because most likely they're older, they're not interested in reproduction anymore. You know, I've had all my kids, I'm done type thing. They're not what you want. They're old and cranky. You would bring the young ones on who have their full reproductive life in front of them, much more likely to be able to survive once they get off the ark. So it's not a matter of whether there wouldn't be enough room. You're just not, people are just thinking. See, they're not discerning properly. They're buying into all the silliness that's out there. So we can easily put the most massive dinosaurs on the ark simply because we just put the young ones on, and they're going to be that big. All right. Also, we have to bear in mind that Noah was, what God brought to Noah was kinds of animals, not species of animals. It's not the same thing. This is where Charles Darwin got himself in some trouble. He thought kinds of species were the same when he began to look and think the species must be changing, therefore kinds must change, and the Bible must be wrong. He didn't stop to think, well, no, maybe you're wrong in understanding what the Bible's saying. See, species is a human classification, kinds is God's classification, and you know what? As amazing this may sound, God's under no obligation to conform to our ideas. You know? He's under no obligation to fit what we're thinking of. At the time God created, species represented the lowest division of animals, but since then, kinds represented, but since then we've had species come in. And that's different. We have very good evidence to say that probably lions and tigers and jaguars and even your house cat belong to the same original kind, but now they're different species. And we can genetically show you how that occurs. So what Noah had on the ark, being kinds, not species, would have been much, much less number of animals than you'll hear critics often throughout today. Oh, you can't get 335,000 species on the ark. I don't need to get 335 species of animals on the ark. That's not what we're talking about. Plus, species is really not very well defined. And I can testify to that as a biologist. It's contentious all the time. Is that a different species or not? Many times we don't know. Which is what amuses me about fossils. We'll find a piece of one fossil and suddenly it becomes a new species. We don't even know if two animals living side by side are the same species or not half the time. How in the world do we know what that fossil is? Many times in science they just make it a new species because that's what you can publish on. It's not as likely to publish as the same species as 6 other people have discovered. See, so we make it a new species simply because that's what gets to be published. And it's a philosophical, it's called lumpers and splitters. Do you lump everything together or do you split them all apart? So even the term species is not very well defined. See, so the simple fact that species doesn't equal kinds doesn't mean that kinds is limited. It means the species is limited. We don't understand all of God's nomenclature, all of his taxonomy, because it's his. He only reveals it to us in small pieces as we study. Hey, little Johnny, my dad says dinosaurs never lived. God just put their fossils in the ground to test us. Yeah. I'm sorry to say that this is out there. Fortunately, it's not very common. And you're not going to read it really in any legitimate creationist book. But it is out there from time to time. And of course, again, our critics love to grab onto this. That their cousin's uncle's neighbor's golf partner was told this. Therefore, that must be what creationists believe. And so we do have to contest with this, that the idea that God would put fossils in the ground to test us. Okay, first, I dismiss that doctrinally because that makes no sense to me. Why did God even do that? What would be the point? But the simple fact is that we have a lot more than bones. We have footprints. We have fossilized raindrop. You guys were talking some about how long bones would last for the fossilized. We have raindrops fossilized. Yeah, raindrops fossilized. So I guarantee you, how you see a raindrop splash in the mud, how long is it going to last? Yeah, not very long, because another raindrop's going to come along and splash into it and mess that up. See, so that tells you raindrops hit that mud and then poof, it got buried very quickly. All right, so we have footprints. We have a lot of bones. So there are a lot of fossils around, not just of dinosaurs, but of all kinds of creatures. As a creationist, I have no problem with fossils because, again, as I stated earlier, I see these as a snapshot of the life that existed on the planet at the time that the Great Flood occurred. Okay? What causes fossils to form? Well, you have to have rapid burial. Water very much accelerates formation, and the more water, the better. And even this museum stated that, because that's fairly well accepted. You have to have a lot of water, burying creatures very quickly to give you fossilization and to give you the best fossilization. Are there any current processes giving us fossilization? No, not really. Not really. And this is something that geologists struggle with because when we creationists come back to them and say, what's a process to account for massive graveyards of fossils? A process to account for 5,000-foot salt beds. A process called for 250 feet coal beds. What's a process today that accounts for those? They have to reluctantly admit there is no current process that accounts for those. So clearly something was very much different in the past than you see today. And we want something that would have a lot of water and would bury all of this very quickly. And what would that be? Well, guess what? Noah's flood fits all of that criteria very well. Okay. Most dinosaur fossils are also what we call disarticulated. You know what that means?
They're all in pieces.
Right, right. You're going to find one bone here, and one bone here, and maybe a bone over there, and they probably don't even belong to the same creature. Yeah, when you find 30, 40, 50, 60% of a particular dinosaur fossil, the first thing that rings in your mind is ka-ching dollars. And if you find 80 or 90% of the fossil, then it's ka-ching, 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 because you got a lot of dollars there. Museums will pay sometimes millions upon millions of dollars for 80, 90% of a dinosaur fossil because it's so rare. Most dinosaur fossils, it's one bone. I've done several digs up in the Hell Creek Formation in eastern Montana. The dinosaur fossils there are so prevalent that you just reach in the ground and you can bring them up, but they're all in tiny pieces. They're all fragmented. They're not even single bones, they're chips of bones. So sometimes even just finding a whole intact bone is not trivial. But there was so many bones that have been so broken up that they're just all over the ground. Another thing that I find fascinating is if I'm digging in the ground and I have maybe a vertebra of a triceratops, I go over 10 inches and here's a shark tooth. I go over 10 more inches and here is a piece of a shell of a marine turtle. Now even evolutionists will admit those creatures did not live together. How did they get together? Obviously massive water action for them all together and buried them right there. Okay, so what is the significance of dinosaur fossils being highly disarticulated? The significance of that is that they were violently buried, not slowly buried, not gently buried, not gradually buried. They were violently buried. In fact, several smaller intact dinosaurs and other animals have a unique position. It's called the death pose. Anybody know what typically causes this death pose? Head turned back like that. Drowning. Drowning. So they drowned and were buried simultaneously. Okay. There's many fossil beds of dinosaurs. There's one fossil bed in particular that's very interesting, found in Montana, that contains up to about 10,000 individual duckbills. They're almost all disarticulated. They were busted up, so they were buried with violence. The bones are also, for the most part, directional, meaning they're going east to west, so it tells us the flood waters were coming from the east and going to the west. Okay, so it wasn't multiple events, it was a single event. And here's something fascinating. What I find amusing, and if you noticed in the museum, they talk about hadrosaurs. They said, well, they had families, they cared for the young, etc., etc. You know, most of that comes from this fossil bed. Evolution is interpreted, well, see, it proves they traveled in packs, which it might prove they traveled in packs. You don't know. It just proves they were buried in a pack. But how can you say how they took care of their young if there's no juveniles in the fossil bed? It doesn't tell you how they took care of their young. But what I find fascinating, any guesses why there's no juveniles in this fossil bed? I only have two.
Only two. What did she say?
They were on the ark. Yeah.
They ate their young.
Yeah. What happens in a stampede?
Those of us that are older, we just run slower.
And those of you that are small, you run slower. And it's interesting, in a stampede, mom suddenly isn't as interested in little Junior. And little Junior gets left behind. And so this fossil bed actually is fascinating evidence that these creatures were apparently running from something. And then still got buried. Wonder what that could have been. All right, dinosaur evolution. If you go into a textbook, you'll probably see something like this. I'm almost surprised they didn't have a picture like this in the museum, but you'll see something like this. See all this wonderful evolution and how this all works. And you see then what they'll do is they're going to connect everything together to show you this nice evolutionary tree, except what I have in this picture is all the speculative. In other words, there's no fossil evidence at all. Not even teeth or pieces of joints or anything, no fossil evidence at all. I put that in blue and red. So when you remove zero fossil evidence from this tree, this is what it looks like. Where's the evolution? See, in other words, these have always been, you know, the Triceratops always been the Triceratops, the T-Rex always been the T-Rex, the Hadrosaur's always been the Hadrosaur. There's no fossil evidence of any kind of commonality of evolutionary descent. All right, so let's move into some of the work I've been doing in the lab the last few years. We're going to form a fossil. We want groundwater. We want a lot of groundwater. And here's what's happening. The groundwater is going to move silica into the bone. That's why I want it buried, so we can get to the groundwater and the silica. Then move silica in the bone is going to pull calcium phosphate out. And it's called replacement. We're going to replace the calcium and the phosphate, the phosphorus, with silica. The primary, not the only, but the primary element in fossils is silica. Not the only, but the primary. So my question is, how long does this take? One would quickly reason that this can't take millions and millions of years because there'd be nothing left of the original bone after millions and millions of years. So we would, even in the evolutionist circles, they would have to conclude that obviously this is a process that's going to occur rapidly enough that the bone's going to be able to remain intact, so you're going to have an intact fossil. Because if it takes too long, then portions of this bone are going to decay out. But I also ask the question, how long does this take? Because what we're finding is that the fossils aren't fully fossilized. Now, I have some data sitting on my desk that I'm not presenting here because it gets a little technical. What we're finding is that some of these dinosaur fossils not only still contain tissue and fragments of proteins, but they still contain the native composition of the elements of bone. In other words, they're still bone. They're not fossil. They have zero silica. Yeah, that's right. That's what I said too. Wow, look at that. It's still fossil. It's still bone. No, not the whole thing, but it'll maybe be a segment here, and a segment here is still unfossilized bone. To say, how long does it take to fossilize a bone? And if it's supposedly 70, 80, 100 million years old, how do you still have unfossilized bone there that hasn't decayed out? Okay. This, in fact, was published, some of this work was published in Science in 2005 by evolutionists. In fact, one of the evolutionists discovered the duckbill graveyard that I was just talking about. But the most common person associated with the pliable soft tissue is a scientist named Mary Schweitzer. And this was part of her dissertation work, even though she'd already graduated several years earlier. Okay. They found in the femur of a Tyrannosaurus rex pliable squishable tissue that still contained fragments of proteins. This brings in the Creation Research Society. We wanted to get involved in this also, so we started what's called our iDino project. It stands for Investigation of Dinosaur Intact Natural Osteotissue. We wanted to stand for iDino, so let's come up with something. Okay. All right, so this is some work we've been doing. Okay, and remember, the Creation Research Society is funded strictly by private donations. We do not get any government funding. We don't get any funding from the Howard Hughes Foundation or anything like that. Okay, because we're those bad, evil, wicked creations. So we rely on people such as you to fund our research. Okay, so we've been doing for several years work on soft tissue as well. We published a lot of our results in this is our publication, the Creation Research Society Quarterly. I think we still have a couple of them. This is a little technical. We're going to get into the technicalness of what we found. Okay, I also have written a book called Echoes of Jurassic, and we have a video called Echoes of Jurassic. I tell people, watch the video, then read my book, and then read this. And that'll get you really pretty much informed on the topic. Which, by the way, I got to put in a plug, our video has won a few film festival awards. So pretty good for a science-heavy documentary. Yeah. Okay. We did some digging initially in 2012, been several times since. In 2012, Hell Creek Formation in Montana. And what we found the first time, we found other fossils since, but the first time what we found was we found an extremely large Triceratops brow horn. In fact, it was 46.5 inches long. And as you can see here, this isn't the end of it. The end probably extends out even further, so it's probably closer to 50 inches. This is massive in size. In fact, the museum people that were serving as our guides were just beside themselves because this was the largest, in their understanding, this was the largest Triceratops brown horn found, certainly in eastern Montana, if not in the entire state of Montana. They wanted to put it in a museum. We said, no, science has a price to pay. We took and broke it up. It's now in small pieces because we wanted to look for tissue. I have since found out that apparently this particular picture is one of the most popular pictures on the internet. And I couldn't believe it when we came to run across this. It's just all over the place. And I get amused because even though I don't get any credit, this is my arm right here. I need somebody. All right, so some of the work we did, this is a piece of tissue we pulled out of that brow horn. Now, let me back up just a second as I show you what we found. Notice the brow horn, it's exposed here on the end of this cliff. So it's not like it was somehow sealed in a hermetic tomb. It's exposed. Rainwater, groundwater, microbes, insects, plants, all had access. This is only about a foot down, so it's not like it's also buried 20 feet down. So it's very exposed to the elements, very exposed to temperature fluctuations. And yet, even though it's supposed to be 68 million years old, nice, stretchable, pliable, squishable tissue. You know what these are?
Striated muscle.
No, those are bone cells. Because this is bone tissue, not muscle tissue. Yes, osteocytes. Exactly. Exactly. In fact, here's electron microscopy of those. These are dinosaur bone cells.
So they don't have the same horn as a rhinoceros made out of hair? Or?
A rhinoceros horn and a triceratops horn are not the same, correct.
Okay.
Rhinoceros horns are mostly keratin,
Okay.
and they're hollow in the middle. And this would be a little big for rhinoceros. It'd probably fall over. It would have been a little big. Rhinoceros horns are typically about that big. This one was this. So you get an idea. And yet we've been accused of that. Well, you just, or also been accused you found an Ice Age bison horn. Ice Age bison horns were about that big around. This thing was that big around. And it wasn't in Ice Age layers either. It was in Cretaceous. It's in Hillcrete. No, Ice Age in Hillcrete. We also, another fossil we found, well actually we didn't find it per se, it was given to us many, many years ago. A Thesliosaurus was uncovered, and here's its spinal column, it's its vertebra. This end piece was so damaged the museum didn't want it. So they just put it in plaster Paris, wrapped it in aluminum foil, put it on a shelf. So there was no special care taken of it. Just put on a shelf. They had an intern last summer that wanted to learn some of the techniques we were doing, so she brought this piece down to my lab just as a piece to work on. And one day I said, stop. I turned the camera on. I said, pull.
That's moisture. That's
Now it's been soaked. You can't do this dry. Right, it's been soaked. Yeah. And then once we pulled it off, and we pulled several pieces off, once we pulled it off, then we have this. So you can throw that thing on a grill and have dinosaur steak. See, that's tissue. You are looking at dinosaur tissue from a bone. Of a fossil that wasn't even particularly taken care of very well.
what did they say when they found out what you?
Well, the people working on this same area, they don't question it because they're finding the same
No, but I
thing.
mean the people that essentially donated it to you.
Oh no, they were thrilled. They were thrilled because it's a creation. If you're familiar, if you're ever in Montana, if you ever happen to be in the east side of Montana, because Montana's a big state, there's in Glendive, there's a dinosaur museum, and it's really very well done museum. And so they're the ones who work with their creationists. Now they get us onto land that wouldn't necessarily be all that positive for creationists, but they get us onto that land. So we're able to use them as our go-betweens. Other research of other labs have isolated, for example, blood vessels. These are still stretchy, pliable, translucent, still have all the characteristics of blood vessels. Out of, for example, this is out of a hadrosaur, right? And in that blood vessel, they found all these different proteins. Now, if you know much about biochemistry, you recognize that to varying degrees, proteins are really fairly sensitive to the environment. They break down fairly rapidly. So then the question is, how in the world can you have in a fossil buried in the ground, so it's not like it's in some kind of refrigerator, it's not like it's in some kind of soft, safe condition. It's in a fossil in the ground, retaining fragments of all these various proteins that decay fairly rapidly in normal settings. And so what you have is a situation that evolutionists are working very much to explain today of how in the world could this happen. In fact, in 2015, an article in Nature Communication referred to as the common preservation of tissue and proteins. They're looking at it as, oh, this is a new and exciting way to do paleontology. No, it's not that big a deal anymore. Okay, so additional studies now have established that pliable tissues found in a variety of dinosaur fossils by a variety of labs. It's not just an artifact found in one lab. Okay? That morphologically distinct cells are present in this tissue. That collagen fragments, which is collagen is the most dominant protein in bone. Probably the most dominant protein in your body, period. It's the most dominant protein in bone. Collagen pieces are frequently detected in all kinds of fossils, not just dinosaur fossils. In fact, there is a Cambrian beard worm, 550 million years old. They've found collagen. 550 million years old. Now, I accuse the evolutionists of being a little bit like, with billions of years, like Congress is with billions of dollars. I'm old enough to remember Everett Dirksen. And Everett Dirksen once said, you know, billion here, billion there, pretty soon you got real money. And I would challenge that evolution look like, oh, million years here, million years there, pretty soon you get significant amounts of time. It's like a million years doesn't mean anything to them. So the idea that a half-billion-year-old, and it's not just this beard one, there's several, a half-billion-year-old fossil still has tissue, still has fragments of proteins. Oh, it's not big. So we're not talking longer about 60, 70, 80 million. We're talking about 500 million years. And it still has biological material in it.
Don't make no jump.
Other proteins such as actin, myosin, and tubulin are found as well. And even if they want to argue, well, collagen is pretty tough protein, and it is as far as proteins are concerned, it's pretty tough. But actin, myosin, and tubulin aren't near that tough. They're not going to last 60 million years, 70 million years, 80 million years, and yet they're being found also in these dinosaur fossils.
Dr. Anderson?
Yes.
So what do you think should be the amount of time that this would degrade into nothing?
Well, see, we would look at it as if we say these fossils are buried by the flood, which we think is totally scientifically and biblically consistent, and we look at the conditions they're buried under, then even though it's a little surprising if there is still tissue, we would say that's still consistent with the time frame of the flood being some 4,000 to 6,000 years ago.
But do we have evidence today of like human bone tissue in that? How long
In fact,
that does last?
A little bit. Most of the work being done isn't necessarily involving going back and looking at humans per se, because, see, evolutionists don't publish on that so much because humans aren't old enough. And a lot of times, see, humans aren't buried in the right conditions. They're not finding human fossils buried in the flood. They're buried in different conditions, so it doesn't create fossilization the same way. So it doesn't really apply quite the same way.
So we're not really studying anything that would be
What we're studying is models. And you have to understand science a lot of times is a model, because remember, this is historical. We can't go back and reproduce all this. So all we can do is develop a model and say, this is maybe how it could occur. So what we're doing, for example, this is something going on in my lab right now. We're taking and breaking up pork bone and we're putting it in various conditions. And we're going to monitor protein decay and see under what conditions would the protein decay slower than other conditions, and see what's physiologically appropriate and what is something that, well, that wouldn't be a condition that would happen naturally. So that's the kind of work being done. In fact, in light of your question, biochemists who study what you're talking about, they study degradation of proteins in bones, they study archaeological samples and such, they don't believe this. They don't believe it. Because they're saying, I know better. Proteins cannot last 70 million years. Talk to the hand. So the biochemists that understand this, they're forced to either rejecting evolution or rejecting the data. Well, guess which they're going to do? Yeah, exactly. Because they know these proteins could not survive. Just that simple. Okay, Mary Schweitzer, I mentioned earlier, who's been one of the big researchers in this area. She, in an interview a few years ago, made a comment that this leaves us two alternatives for interpretation. Either the dinosaurs aren't as old as we think they are, or maybe we don't know exactly how these things get preserved. Fair enough. Fair enough. Here's the problem. It's not an open topic. That's not on the table. So it's not really an either or. We're not allowed to talk about dinosaurs not being as old as we think they are. All it is, okay, we go back and figure out a mechanism of how this stuff can be preserved in these very, very old fossils. So she gives this nice either or, except that's not the reality of it. It's not an either or, because you can't talk about dinosaurs being younger than these millions of years. So I would challenge that the presence of the tissue and the protein fragments is a direct biochemical challenge to the assigned age of these fossils. And if they did not assign correct ages to dinosaur fossils, then they almost certainly did not assign correct ages to the other fossils, and that also means they did not assign correct ages to the rocks. So the whole column that's presented here with all the dates and such now topples over. And you may be feeling like this right now. So I would open it up for a few questions if you have any. Thank you for your patience, your attention. Any questions? Yes.
So, is there enough there for a DNA profile?
Good question. We have several problems when you're working with DNA. Problem number one is DNA is so easy to contaminate that you have to literally have the fossil in a sterile environment, even almost in the ground, you know, and that obviously isn't going to happen. Okay, so number one is it's very, very hard to say for certain this DNA is not some type of contamination. Until they would find a long enough sequence, they could actually say, no, there's no creature alive today has a sequence, it has to be the dinosaur. Okay, that's problem number one. Problem number two is if I come up and I say, oh, I found DNA in dinosaur, guess what happens? You're an idiot. I don't believe you. That's stupid. Go away. You're going to get a high level of ridicule. Most scientists don't want to endure that, so they're simply not going to do it. Okay? Number three, what happens is I found DNA in this dinosaur fossil. But I am scared to death to publish it because the first thing that's going to happen is those nutball crazy creationists are going to go wild over it because they're going to say, so this proves what we've been saying all along, because no one's going to say dinosaur DNA, no one's going to say DNA could survive for 70 million years. So I don't know if I'm going to publish it or not. I mean, part of me as a scientist wants to publish it, but their flack I'm going to get from the evolution community, maybe I won't publish it. Number four, Mary Schweitzer, for example, has done some work where she used a stain called DAPI, D-A-P-I, that's the abbreviations of it. DAPI binds specifically to a particular structure of intact DNA. And she stained some of these dinosaur cells with that DAPI, and what she found lit up was just one specific region of all of the cells, which would be where you would expect in the nucleus the DNA to be, which is not indicative of contamination, because contamination should be all over the place. And so, no, you can't prove it's DNA, you can't prove, because you can't get a sequence from it, but that is very enticing evidence that there's DNA present, which is why the DAPI found. That's basically all I say, because I'm not going to say DNA's been found. I'm not going to say DNA is going to be found, but I am going to say if DNA is found, then the evolutionists are really going to be scrambling. That's even more difficult to explain its preservation than proteins. Yes?
The human paleoanthropologists have had a lot of success searching for DNA in teeth, human teeth. We have some human dinosaur teeth, don't we? I'm sorry, dinosaur.
Have dinosaur teeth, correct.
So wouldn't that be a good
Correct.
place to
That would be a good place
DNA?
to look. Yeah, that would be, if they're actually willing to do it. I'm not equipped to, because I don't have a sterile laboratory to look for DNA, so it's not something at the moment I can do. So we are, in this case, unfortunately, relying upon evolutionists to be willing to do it. Time will tell. But yeah, the teeth have proven to be a good source of DNA in other fossils and other bones and such, yeah. Or in other specimens, is the way to put it. Yes?
So, in all these digs, you're finding the dinosaur bones and you're finding the soft tissue in some of these digs, are you finding any human bones mixed in?
No. And we don't necessarily expect to. I have a whole lecture, because that's one of the questions, well, how can we not find humans? You're going to tempt me to go to my notes, but the real quick of it is, we don't really necessarily expect to find humans. If you start running the math, you begin to find that the odds of finding, even if every human that lived at the time of Noah was fossilized, the odds of finding a human buried alongside any of these is astronomically low, simply because you're talking about such a massive area. And humans don't fossilize well, because humans, by and large, during the flood would have done what?
Oh, well,
Yeah.
it would have for a while.
Yeah. Much better. Remember also the tsunami that hit Japan? What happened? The animals and the humans separated. How many animals died?
Poor animals.
There's no reason, first off, that the humans and dinosaurs would have been living together. So we wouldn't even be in the same ecological niche. So, this is another mistake that a lot of our critics make, is they assume a flood would have provided this homogeneic mix. And there's going to be some mixing going on, but we recognize what is most of the fossil record. Most of the fossil record are going to be marine crustaceous creatures, hard-shelled creatures. That's 95% of the fossil record. All right, so already to be a vertebrate, your odds of being found as a fossilized form are much less already, which tells you how many dinosaurs and other creatures there must have been on the Earth at the time. So when you get down to finding something like squirrels, dogs, and cows and such, you see the percentage of those that fossilized are so small. And part of that probably is because the ecological niches they were living in, they weren't buried sufficiently for proper fossilization. The flood also wasn't simultaneous. It didn't flood the earth in one day. Remember, the Bible says it took weeks and weeks and weeks to build up. So what's the first thing to be buried? The first thing to be buried is your low water sediments, which is probably the Cambrian, pre-Cambrian, what we call it today. And then you come up higher and higher and higher, see, and so you're catching these ecological niches as you're going up, which is why there appears to be some zoning in the fossil record. It's not because of evolutionary transformation, it's because these are ecological niches, it's snapshots. Humans, by and large, would have been the most likely to survive because they would have been the most rapidly doing things like trying to grab stuff to float on and trying to build boats and everything. And so their being buried and fossilized would have been much, much less even than other creatures that weren't likely to be fossilized. So it's not totally unexpected that it's really not that unexpected that we don't find much in the way of human remains. Plus, anybody know what I mean when I talk about the Cambrian bunny paradox? All right. Bunnies didn't live in the Cambrian, so if you find a bunny fossil in Cambrian rock, it must not be Cambrian rock. the way it works. So what it is if you find a human fossil, then that obviously means it either got inadvertently put there somehow, contamination intentionally put there, or it's obviously not Jurassic Cretaceous rock. The presence of the human fossil already reclassifies it. So even if something was found, it wouldn't be identified as such because that can't be. I know that's almost too simple of an answer, but I don't have a half hour to explain it all to you. But there are what I would consider very reasonable, rational explanations why we don't find, alongside all these dinosaur fossils, all the human fossils. Yeah.
What evidence is there for radiometric dating being accurate, and how would you refute that evidence?
The evidence for it being accurate is if you accept the assumptions. And the assumptions are, one, that radiometric activity is constant. All right, there's some challenges whether it is or not, but let's go ahead and pretend it is, just for the sake of argument. The second assumption is that there was zero, when I talk about parent and daughter, you know what I mean? The parent is the radioactive element. The daughter is what it decays to. So uranium decays to lead. Potassium decays to argon, as examples. So potassium is the parent, argon is the daughter. All right? So assumption number 2 is that the amount of argon in the lava, in the rock, started out at a certain level and never changed except for radiometric decay. In other words, there was never any added in or taken out. And the third assumption is that there was no argon, there was no daughter to begin with. Because if you obviously had some daughter in there, then that would mess up your clock, because you would think that came from radioactive decay, and it didn't. But here's the interesting point. Argon is there. It's called parentless argon. How do you know it's parentless argon? You know it's parentless argon because it's causing the age of the lava to be too old. Stephen Austin went to Mount St. Helens. Right? He collected samples of the lava flow from Mount St. Helens. All right? Mount St. Helens a few years ago. You would think it was ancient history because it was before you were born, but some of us still remember it, all right? So it's not that long ago, all right? So we know when Mount St. Helens occurred. And he did potassium argon dating on that lava, and he got an age of 330,000 years. Okay, wow, it's not 330,000 years old, it is 20 years old at the time he took the sample. What happened? Well, it's parentless argon. It's argon that got trapped in there during the lava formation that didn't escape. So we know it's parentless argon because it's not the age we need it to be. And I'm supposed to rely on that as a dating method? And my challenge has always been back to the evolutionist, how do you know when it's parentless or not? You have no way of knowing. If I go over here and find another piece of lava and date it also, how do I know how much parentless argon's in there to begin with? Well, it's what age it gives you. Well, now wait a minute. Am I using, yeah, exactly. Am I using the radiometric method to determine the age, or am I using it simply to justify my claim of the age?
Are they evolutionists or illusionists?
Sometimes they wonder, yes.
Okay, I think, one more question.
Yeah, I just have a question. When you're talking about the juveniles being left behind, some of the dinosaurs that they portray as little dinosaurs as another species, but those not in the juveniles.
Now, they weren't in this bed, but clearly, I think, and again, I'm going to be careful in speaking because I'm not a paleontologist, but clearly there have been examples over the course of paleontological study, where they've come back and recognized, oh, that's actually the female of the species, or that's actually the juvenile of the species. So there was an initial misidentification. Yes.
Thank you, Dr. Anderson.
Thank you.
I didn't get a chance to introduce Dr. Anderson before he started here, which is fun because we'd rather hear him talk than my introduction. But I just want to tell you a little bit about him. He does have a degree in microbiology from Kansas State University. He also went on to the University of Illinois to start his studies at the National Institute of Health, as a postdoctoral fellow. And later he became a professor of microbiology at Mississippi State University. And there he taught graduate level molecular genetics courses, and also was the major professor for many doctoral and master's students. He served as a research microbiologist for the United States Department of Agriculture, and since 2003, he's served as the director of the Van Andel Creation Research Center for the Creation Research Society. He's also presently the editor-in-chief of the Creation Research Society Quarterly. One of his main areas of research, as he talked to you about, has been the molecular analysis of bacterial interactions and molecular genetics. He has over 20 papers in scientific microbiology journals and has given presentations at many nationwide and worldwide scientific meetings. And he mentioned his DVD, which got multiple awards, Echoes of the Jurassic. It's over here. Highly recommend it, along with the book. His wife Diane is over here, and they're both from the Creation Research Society, and they have resources over here if you'd like to take a look at them. So now, first of all, thank you for coming. And for those people that were in the 9 o'clock tour, you're free to go, and you're welcome to explore the museum as much as you would like to. If you want to go to any of the special exhibits, then you have to go get a ticket to go into those, like the Vinci Scrolls or the IMAX or anything like that. But all the rest of the museum is open to you if you want to explore it. The next tour will start at 12:15 here in this room. So if you're in that tour and you need to get lunch, I urge you to grab something. You can also grab it and bring it back here as long as it's from the cafeterias here. So if you enjoyed this tour and lecture, please let us know, or write us a note at info@Denver Society of Creation. If you have some suggestions, we're also interested in hearing those. Just give us a note. If you'd like to have some more information on the Denver Society of Creation, we have brochures back there. We also have business cards. This gives you all the information about our website, our Facebook page. And we also have a newsletter. So if you'd like to sign up for the newsletter, you can do it, and there's a sheet back there on the table, or you can go to our website and sign up also. Did I forget anything? Okay. And we did video this. We videoed all of Dr. Anderson's talks this weekend. They will be available on our website as soon as I can get them put up there. So if you would like to see them again or show them to your friends, they'll be up there for your viewing. Okay, so if you would like to get lunch, you're welcome to do that and try to be back here just a little bit before 12:15. Thank you.